Hey you! So, as you can see, I'm very happy because I'm back in my office. Yay! My real office, not the one at home that sometimes my wife kicked me out of it. So, now that we know more about process model, let's take a look at more cool features that it have. Like it's a very complex software. There's tons of things that we're not gonna go over. Okay, that if you want to, you can go and watch some tutorials and videos about it. Because there is kind of a bunch of stuff that is very complex and can adapt to what kind of process you have. Okay, so we're going to do some basic stuff. So know what to do when we find that problem, and you know what to do, to create pretty interesting still process models. But we're not going to go over everything, right? So one thing is we kind of slightly talked about was the entity arrival option. So here I have some options that you can have. You can input some daily patterns saying that, okay, let's say that you're trying to put a process map on Starbucks, right? So you know that between, I don't know, 8 and 10, you have a lot more people coming, then you have less people coming, then you have more people coming in the afternoon. So you have some patterns and they repeat it, every day of the week. So that's the daily pattern that you can put. So it could be periodical and repeating intervals of time, and some of the examples are more on the periodic side, right? That we saw and did online together. And also you can have some schedule, right? So maybe you have a time that you know that the customers will arrive. I don't know, you're doing a doctor's office, you know that this time that many people arrive, this time that many people arrive. That's also something that you can use as arrival patterns. So for the periodic arrivals, you can use a lot of different cool distributions for that, right? And here we have some of the ones that we're going to use more, right? So we use a lot of this exponential and normal distribution or triangular distribution, right? So it depends on, let's say you collected data about the frequency of people coming in, and then you can see what kind of distribution does it look like, right? So we did have several capstone projects. We put it in a histogram and say, okay, what are we going to get? What are we going to put, right? Exponential is the one that we saw usually, used for arrival rates, right? Because that is the distribution that we frequently use, and we saw that on the waiting lines, like example that I can go back really quick. Boom! Remember this one? Yeah, we looked at really quick, right? The Poisson distribution. That's usually the one we use for arrival rates. Do my magic here, and we're back. Normal distribution. So the way to write it down. So here we have a normal distribution, right? The way to write it down is n and mean, comma, st, the standard deviation. So what will be the mean? In this case, the mean is 30, standard deviation is 5. So we have an n, 30 the mean, 5 is the standard deviation, and you have a normal curve, right? A bell-shaped curve. But remember that if it's a normal distribution, it's an infinite number on both sides, right? And that's the difference between the triangular distribution. So it looks like a normal, the shape, kind of, right? Roughly. But the difference here, the triangular, it's that there's a mix and a max, and what you're putting in the middle is the mode, right? So 2, 5, 12 means the minimum is 2, the mode is 5, which is the highest frequency point there, and the max is 12. So, if you compare that to the normal distribution can be infinite to both sides, and the triangular, no, you've got to have a cap and limit it 2 to 12, right? And sometimes that works better because you don't have 100 people arriving in the moment, and it's very unlikely, but it might happen. So it kind of set parameters usually a bit better. Uniform distribution, so that's the uniform is here. So we have the mean and a half of the range. So this is a uniform 20,4. So 20 is the mean plus or minus 4. So any value from 16 here to 24, it has the same probability. Same probability to any value between 16 and 24. That's what the mean the uniform distribution means. And the normal, it's not, or the triangular, right? It's be more likely to have things around here on the triangular, more likely to have things here on the normal distribution. Uniform is a uniform, right? A probability. And you can define also, you can have some values here, say no, there's 3 options. It's either coming 2 people or 10 people or 100 people, and you have a probability of each one of them compared to each other. So that can happen. Some cases. So there's the user defined logic here as well, where you have to say the probability and the value in each one of those cases here, right? So 35, 37, and 45 are the actual values, and the 20, 30, and 50 are the probabilities. Okay. Here we have some examples. So we have example 1 and 2. So here I have a periodic. Here is to do this is just double click on that arrow with the first arrow, right, from the entity going out, and have 2 arrows. The arrow top. I don't know what that part of the arrow there. And you're saying that it's repeating every 1 minute. And the quantity of arrival is going to be 1, and you're starting at 0, right? In this one, I'm using a T, like a triangular distribution, 0, 5, and 20. So the mode is, it's going to be 0, 5, and then 20, right? And the quantity for arrival, I'm determined to be 1 or 3. So there is 60% chance of every time that something arrive 1 at a time. There is a 40% chance of arriving 3 at the same time, right? So that's the user define here, okay? And it will start at 1. So that's what basically I'm saying in this example.